Hi everyone. So if you have any doubts from the last tutorials, you can ask. So I just shared the screen. Can you see the screen? Okay. Yeah, so if you have no doubts, then I just start. So today we will discuss about Gershkovin. I think the name is like this, Gershkovin circle theorem. First this, and then we will go towards the power method. Yeah, so I'm just going to do with this book again. So what is this theorem says that? So last time I've just recalled that you have to see how this works, but now I'm just telling like proving it a bit so that it can be understandable. I hope you already know what is eigenvalue that I've already discussed before and the eigenvectors as well. So what does it say? The largest eigenvalue in the modulus of a square matrix A can't exceed the largest sum of the moduli of the elements along any row or any column. Okay. So what does it basically mean? So if you take any eigenvalue of A, then it cannot exceed the largest sum of moduli along any row or any column. So I just recall it. So if you have a matrix A which is something like A11, A1n, AN1, ANN, then it says that so if you consider the sum along the first row, so if this is the first row, then you consider the sum. Okay, then this is the row sum. Row sum is this. Okay, then the eigenvalue. So lambda is eigenvalue of A, and lambda, absolute value of lambda can't exceed the maximum of row sum. So maximum over all rows, say I equal 1 to n, and then you have AI1, AI2 up to AIN. That's so it can't exceed the maximum of row sum. Likewise, you can define what is your column sum, and then you get this result. Yeah. So how do they get that? Just see that once. So if lambda is an eigenvalue of A, and since lambda is an eigenvalue of A, x be the corresponding eigenvector, then you just write AXI equals times a lambda times x, because lambda is eigenvalue and x is the eigenvector. So which in detail can be written as, so xi can be multiplied with the matrix, so you get some equations because A is a matrix. So you are gonna getting like n equations in the system where xik modulus is the maximum over mod xi r's. Okay, suppose it happens, then you just take the kth equation in above and you divide it by xik, and you get lambda ik something like this. Then and lambda ik is less than equal to this, because you know xi1 is less than xik, because xik is maximum of xirs. So this all quantity in the bracket is less than 1, so hence it is less than a1 ak1 and so on. Yeah, that's the reason. So lambda I is less than the row sum. Similarly, you have column sum. Since it is less than each row sum, so you say that it is less than maximum row sum, and hence this theorem. Is this clear, everyone? I hope this is clear. If you have any doubts, you can ask. Okay. So this theorem is very, very useful in solving some questions based on that, where you need to find out the bounds on the eigenvalues that I'm going to discuss later. But we have another theorem that will discuss first. And these theorems will be helpful, I think, for the power method as well. So we will discuss that after this. Okay. So what is Brouwer theorem? This says that, so the first application you have learned is the bound on the eigenvalue is always the row sum or the column sum. That's true. Next is we have to find a precise bound, right? So we have another theorem for that, which says that let Pk be the sum of moduli of elements along the kth row, excluding the diagonal element akk, then every eigenvalue of A lies inside or on the boundary of at least one of the circles. Okay. So lambda minus akk equal Pk. So Pk is the sum of modulus of the elements along the kth row, excluding the diagonal element akk. Okay. So I just go with that. What is this? Okay. I just take another. So A is again your A is same in previous case. A is same in previous case. That is your A like this. Then it says, and Pk is your sum of modulus like AK1. This is your kth row elements AK2, except, so I just write AK k minus 1, AK k plus 1. So AKK is, it goes away because we are removing AKN. So Pk is the sum of moduli of the row elements. So if you look at the matrix, then kth row lies somewhere here. So Pk is that chunk of elements, and you just bring one AKK outside of this. Then what is it? So Pk is very clear, like what is this? Then it says that then every eigenvalue of A lies inside or on the boundary of at least one of the circles lambda minus akk modulus equals to Pk. So if lambda is an eigenvalue, then it must lie in this kind of region, is less than equal to Pk. So I chuck this akk with the lambda and then say that absolute value of lambda minus akk should be less than equal to Pk. And Pk is your remaining term, right? That we have already defined. So it gives a bound, right? It's like a circle. So it's like if lambda is at origin, suppose if lambda is 0, then it's kind of akk is the radius, and yeah, so you get some kind of, what is the circle equation you have? How do you define circle? X square plus y square equals to r square. Yeah. Radius is kind of pk, sorry. And you define your akk in like how much far from origin it is. But you can convert this in this form. So it's kind of circle equation that you will get. And all the lambdas are lying inside this circle. I think it's kind of clear. Everyone is okay. Well, this is the another theorem that is very useful, of course. So just try to do this type of question. So estimate the eigenvalues of the matrix using Gershgorin bound. So I just want you to try this for a couple of minutes and then we will discuss it again. Because there will be so many questions on this, and if you don't practice it, then you won't get it. So just try this one. And if you have any other question in mind or in assignments you want to try on, just try that as well. And let me know if you have any doubts on that. Because I'm discussing algorithms, try questions. Of course, I want queries and questions from your side as well. Just try this. I'm happy to answer.
Excuse me, sir. Hello.
Yes. Yes, Nasir.
Hello. Good evening. So can you just go back to the question, sir?
Yes.
Uh, Actually, I was trying. One doubt I have got now. We have to take along the row modulus sum as well as
Yeah.
column. Now, if you take along the row, first row, mod of lambda for the first row will be less or equal to 4. For second row, it will be mod of lambda less or equal to 3. And for the last one, it will be mod of lambda less or equal to 5. Now,
Yes.
this is about row. Now, I have to again take column. Then I have to compare with row and column. Am I right?
Yes.
Now, coming to the row where I have got mod lambda less or equal to 4, then less or equal to 3, and less or equal to 5. Should I take the union of this for row, only for row? Because I have to compare, no? So should I take a union of all the three and take as mod of lambda less or equal to 5 row wise?
Yes. Yes.
Similarly, column also I have to take less or equal to 6.
Yes.
Then I have to take the intersection.
Yes. Just tell me the final result. Yeah.
Then the answer will be mod of less or equal to 5 only.
Answer will be mod of less than equal to 5. How is that?
Because what my question
But
is, when we are
you
taking,
have considered the Gershgorin theorem as well with circle theorem.
okay, now circle theorem also you have applied. Okay, now coming to row and column, the answer
Yeah.
is mod of less or equal to 5. Okay,
Okay.
now we have to go for circle. Okay, sir, just give me a minute. Thank you. I'll just attention.
Just try.
Excuse me, sir.
Yes.
Sir, so is the final answer after taking the intersection with the
Hmm.
circles also, is it close interval minus 5 comma 4?
Okay, let's see here. So you're getting mod lambda is less than equal to 5 and 6, right?
That is for row and column. Then when you go with the circle,
Yes. You're getting these things.
uh, for a while, union of the circle. Okay, I have taken, and this, and which is the third one, sir? The third one is of union. How we get that? Is it?
On the
See,
columns.
no, sir. My doubt is second part we get by taking diagonal. Am I right?
Yes.
along the row.
Okay, I just do this first.
It could
What's
be
the
along
matter?
column also.
Yes, along the column as well. You have to make.
5, right? 2 plus 3, 5.
Three parts would be there. I think
Hmm.
first they merge together. Okay. This is my pen. So I just show it here. 1 to minus. One, 3 minus.
So is it close interval minus 4 comma 6?
Okay, that's means the overall answer is you have to sketch the circle. So
Yeah, after the intersection of all, close interval minus 4 comma 6.
it should be this region, the lining region in this.
Yes, minus 5 comma 6.
Yes.
Can you just explain, sir, how it will be?
Okay. So first thing you have done is along the row, right? So that is you're getting lambda. And what is this? 6, is it? No, it should be a 5 and this is 6. Yes. So first thing, how you're getting this, because mod lambda is less than equal to maximum row sum and maximum column sum. Is this clear? So maximum row sum is 5. 1 plus 2 plus 1 absolute you have to take, and then it is 5, and maximum column sum is 6. That is already clear. 2 plus 1 plus 3. Now second thing you have to check using Breuer, what is Breuer theorem, which says this is by Gershgorin, and next is the Breuer's. So in this you will get mod lambda minus 1. So if you look at this element, then it is less than equal to sum of these two. So it should be 3. And similarly here as well, and here as well. So you are getting 2, and mod lambda plus 1 is less than equal to 4. So from the first thing you get, okay, so if I plot the graph, that's not a, what is happening? Okay, if I plot the graph of this, why is that? Okay. So mod lambda is less than equal to 5. So you have 1, 2, 3, 4, 5. Then you just 1, 2, 3, 4, 5. It's kind of something like this. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So that is this one. And mod lambda is less than equal to 6 is the big circle. Okay. So you will have another green circle. My drawing is okay. You can do this. So that is the union. So union is the green circle. So green circle is from first part. So first is the union of all these green. So I just shade it with the green color. That is your first region. Is that clear? First is clear. Then you have mod lambda minus 1 is less than equal to 3. So I use orange color. So this is 1, and if you take 1 as something, 1 as the center, then you have 3. It is 1, 2, 3, which is here. I think it is 4, yes. And 1, 2, 3, which is 1, 2, 3, yes. This is 2. So you just take this, and similarly here above 1, 2, 3, and 1, 2, 3. So you just match it these points, and then you get kind of this circle, okay? Mod lambda minus 1 is less than equal to 2. So 2 means you have another 1 point, 2 here, 2 here, 2 here, 2 here. So it's kind of shorter. And mod lambda plus 1 is less than equal to 4. So then minus 1 would be the center in this case. So here is the minus 1. Then you have 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So it's kind of this one. 1, 2, 3. Yes. Okay. And this 1, 2, 3, 4. So this one. Yes. So the union will be this region. Union will be this region. Okay. So now check which region is. Now you have to take the intersection of both. So this region is qualifying. The orange region is coming. Okay. And the other thing you are getting is so last region that again from the columns is how you getting this one, that so mod lambda minus 1 should be less than equal to column, if you see that. So 2. Mod lambda minus 1 is less than equal to the column sum, which is 5. And again, mod lambda is less than equal to mod lambda plus 1 is less than equal to 2. So if you can sketch these maybe by red one, then 1 keeping 1 as a center, then you have to go 1, 2, yeah. So if I use very dark color, then maybe green, 1, 1, 2 here, 1, 2 here, 1, 2 here. So it's kind of this region. And mod lambda minus 1 is less than equal to 5, then it would be the big region. Okay. So this is 1 actually. So 1, 2, 3, 4, 5, then this region. This is outer part kind of. 1, 2, 3, 4, 5. Here. 1, 2, 3, 4, 5 here. So it's kind of this region. Okay. Okay. And mod lambda plus 1 is less than equal to 2 is minus 1, 1, 2. So kind of this region. So you have to take final intercept. That is the union. Union is the big region. So this region is cut by this part only. So this is the whole region. Is this clear now? This is the whole region that I'm showing where the green. I just show with the pink. This is the pink region. Is this clear?
So finally,
Yes.
we have to take intersection of all.
Yeah.
And so the pink which you have encircled, what is the lambda value, sir? Because you have not mentioned the lambda value. So what's the least to maximum lambda value for that pink circle?
Lambda should be like, if it is real, then it should be less than equal to, how does it say? So I just write lambda should be less than equal to 4 or minus 1, minus 3. What is this? Yes. It's for complex. If lambda is like kind of a plus bi form, then you refer to this region. If lambda is real, then you can show what is the last entry point here and here, this one and this one. Is this clear now?
So
Is this
just
clear?
can you show the graph once?
Yeah. So here
The,
we are getting -4 and 4.
sorry, no, the graph which you have drawn.
Yeah. Here also we are getting the same.
So -1, 1, 2, 3, 4, 1, 2. So kindly once, because the pink towards the left, I think it's at the fourth point. I think it will be -4.
Yeah. Sorry.
You have mentioned -3 to 4.
Yeah.
Okay, thank you.
Then it should be mod lambda is less than equal to 4. Yes. Okay, this is clear then, but in the question, like they may give you regions as well, but I don't think so. They will provide you the sketches in the options. So you have to find out the correct value of lambda. Okay. And that's easy to do, right? You have to look only at x-axis, not at the whole picture. So instead of drawing these circles, you can just draw the lines. You can just mark something, intervals kind of. So if I say here, in the exam, you can just shift it here, like you can find out, you can do mathematically. What is this? 3 plus 1, 3 minus 1, 2 lambda here. How does it work? Is it 1? 1 minus 3, oh, minus 2. 3 and 1 minus 2 minus 1. 4 minus 1, 3. Is this clear what I'm saying, everyone? In the exam, you don't need to draw these circles. You just do here like this. And just take the union of these two intervals. Just plot these intervals, -6, 6, -5, 5. Then what is the union? -6, 6. And you have some kind of another interval. Then you take the intersection, that it is the, so you don't need to draw the 2D picture, 1D is fine using. Is this clear? Okay. So that's the main thing. Okay, we will go with don't think so if there is defined. That's not we have discussed. So that's already we have discussed the bounds. Then we go with another method maybe. Where is that? Yes. So this is a nice method which is called as power method that we are going to discuss, and this may have some questions. So in the exam, it is very useful, like some questions based on that we will try, and then we will, yeah. So what is power method? So it is used to determine the largest eigenvalue and corresponding eigenvector of the system. Okay. So Ax is lambda x, lambda is the eigenvalue of A. And if you have lambda 1, lambda 2, and lambda n be distinct eigenvalues such that the absolute value is like this. So you can arrange any eigenvalue in such a way, right? But there is a condition like lambda 1, lambda 2, and lambda n should be distinct. So you don't really need to take all the eigenvalues. Yeah. Okay. Okay, so first assumption is that just assume that A has n eigenvalues and n eigenvalues are distinct. Okay. And V1, V2, Vn be the corresponding eigenvectors. Okay. Then since you have n eigenvalues, you have n eigenvectors V1, V2, Vn. And of course, you can write V in the space of eigenvectors like this. Then you multiply your A by V1, which is of course it is an eigenvector, so A V1 is lambda 1 V1, A V2 is lambda 2 V2, and so on. Since V is like this, so A V you can separate it like this, and hence you can go over like this. So you get AK plus 1V in similar way. I think I need to show you the working of a method by this. Maybe here. So you calculated AV. So AV is this. Then you take lambda 1 common from this here. Then it is just C1 V1 plus C2 lambda 2 by lambda 1 V2 plus Cn. So if you have any problem in each step, just let me know that you get this here. Then pre-multiplying by A again and simplifying B get. So you multiply this equation again by A, which give you A square V. Because A multiply A is A square. Lambda 1 is square. C1 B1. So you are multiplying A again. So A lambda 1 V is V1 is again lambda 1 V1. So lambda 1 is coming again. That's why. And you get this type of equation. Similarly, you get AK plus 1V is equal to like this. So as k approaches to infinity, the right hand sides tend to this and this. Lambda 1 to the power k C1 V1 and lambda 1 to the power k plus 1 C1 V1. Since lambda I divided by lambda 1 is less than 1. So you can bound it by 1, this whole bracket term. So they will turn into this one. So you will get the vector C1 V1 plus C2 lambda 2 plus this will be your tends to C1 V1, which is the eigenvector corresponding to lambda 1. So ultimately you are approximating, you are approximating towards your eigenvector. The eigenvalue lambda 1 is obtained as ratio of corresponding components of AKV and AK plus 1V. You just take AK plus 1V and AKV and you just calculate the limit k goes to infinity, where R is varying from 1 to n. Okay. So what is the procedure? Suppose you have V naught, which is an arbitrary initial vector. You try to find out what is yk plus 1, which is A times vk. Vk plus 1, which is yk plus 1 divided by the largest element in magnitude of yk plus 1. Then lambda 1 is this limit of yk plus 1 divided by vk plus 1. So the initial vector is usually chosen as vector equal to vk. So it is not a very difficult thing. So you just start with, so I just also have to see that steps. Okay. So what you gonna do? Given. So this method is very useful if you don't know how to find out eigenvalue by looking at the matrix. So it's kind of approximation to eigenvalues that you already seen with the polynomial stuff. So given V naught equals to something, I don't know, what's that? V naught is your eigenvector, depends on matrix. So if V naught is 3 by 3, if A is 3 by 3, then it is of 3 dimension, and if it is 2 by 2, then it may have 2 entries, 2 component entries or so on. So you have V naught, then you have Yk, Y1, which is A times V naught. Okay, so you multiply your A with V naught. Then what you will do, just have to recall as well. So Y1 is A times V naught. V1 is, you define V1 as Y1 divided by the m1, largest element in magnitude of yk plus 1. Okay, so what you do is v1 y1 divided by m1, where your m1 is the, since y1 is a times v naught, it will be like some vector, say a b c, then m1 is the maximum of a b c. So you have y1, you have v1, then you have lambda 1, which is limit of k goes to infinity y1 by v naught r. Okay, so you have lambda 1, which is your first eigenvalue, which is kind of limit k goes to infinity. So here I have written only 1, so just yk plus 1 divided by vk over r. R is basically your index ABC, like indexing y. So I just write 1 to n. Here R is 3. So you try to find out what is lambda 1. It depends on how many iterations you are doing. So k goes to infinity. So k can be very large. So yes, so just try this type of thing and we will discuss one example from there and let's try that. Is the method clear? Okay, just try this question then. If this is clear, we will discuss after. Find the largest eigenvalue in modulus and corresponding eigenvector of the matrix. So here, if you look at, then vk plus 1 is the eigenvector and lambda 1 is the eigenvalue. And you have to start by v naught, taking v naught as 1, 1, 1. Just do that and let me know if you have any problem. Just give some time to this, 5 to 10 minutes, and just try to come up with the answer. I want the answer. Yes, have you tried this? Anyone? Okay. So how does it work? So we start the iteration using unit vector v naught. So you calculated y1, which is a times v naught. Are you getting the same thing? I think so. So y1 is okay. Let's go with the same procedure for this matrix. This is a simple matrix, so we just follow this procedure. So y1 is a v naught. V naught is your 1 1. So y1 is a times v naught, which is, what is this? You multiply a by 1 1, which is 2 2. So y1 is 2 2. Okay. So you found y1, then you find your v1, which is y1 divided by m1. So m1 is your maximum of 2 2, which is 2. So y1 is 2, so you divide 1 1, so v1 is 1 1. So you get v1 and y1. Then you have lambda 1, which is kind of this. Okay. So if you go in this way, then similarly you calculate y1 v1, y2 v2 up to the iterations that it said in the question, like you have to do 8 iterations or 9 iterations. If you have to do 9 iterations, just still y9. Okay. And mod lambda will be your, what's that? So in this question, you just calculate yk plus 1 and vk. That's what you need. And you divide yk plus 1 divided by vk. So here, y1 divided by v naught. And over r. And you have to take the max limit of k goes to infinity. Okay, so you first calculate y1 divided by v naught, y2 divided by v naught, and yk divided by, so y2 yk divided by vk minus 1. So this is kind of sequence that you are getting. So that will converge to some number which is called as lambda 1. And your vk minus 1 is your eigenvector. So in this case, if I go there, then how 19.977 is calculated? It is y9 divided by v8. So if you divide minus 19.973 divided by 0.998, then you will get this one in absolute value, of course. And second one as well, and third one as well. Then you, yes, 19.988 divided by minus 1 will give you minus of that. So absolute is the same number. That's so you can verify. So mod lambda is close to 20. So round off to 3 digits is 20. And the approximate eigenvector is basically this, which is your V8. V8 is your approximate eigenvector. Exact eigenvalue is your minus 20, and eigenvector you can find out. So exact is the different, approximate is the different. Approximate you are getting from this algorithm. Exact you can find out manually, that I've already shown. Yes, if you have any doubts in this, just ask me. Is this clear? Because this type of question will come in exam. Any doubts? Okay, if this is clear, then you are better in finding largest eigen. So just remember that power method is giving you the largest eigenvalue of the matrix, and there is an assumption that all the eigenvalues of this matrix are different, distinct. Okay, so 20 is the minus 20 is the largest eigenvalue of this matrix. Absolute eigenvalue it is giving basically. So 20 is the absolute largest absolute eigenvalue of the matrix. And I have already, this is useful because you have already used one type of thing. You try to find out the largest eigenvalue, absolute eigenvalue of the iteration matrix for the convergence. So if you don't know the exact method, then just go by power method. So it's helpful in that case. So you can use that to find it. Okay. Okay, so another thing that I want to focus is inverse power method. Okay. So what does inverse power method says? It basically says that you can find out the eigenvalues of invertible matrix, like eigenvalues of A inverse. Eigenvalues of A minus Ki are 11, 1 minus 8, and that of A minus Ki inverse are 1 by 11, 1 minus 1 by 8. So it's kind of reverse, which is where the eigenvalues are reversed. So it's just a similar thing. I won't go with that. But yeah, this method is useful if you wanna try. Just you have this book, Amkijan. Just try to find out. Just try to solve these exercises if you can. That would be interesting. Okay. I will be happy to take any questions now. If you have doubts, let me know. Just practice like for the algorithms, you need to remember the steps that you should. Although just remember what are the assumptions you are taking in the algorithm, because in the exam they may ask like the assumption based questions like one word. So just prepare for that. And other than that, just I think most of the stuff is till the power method. I don't know if so. We may study the differential equations, I think, next time, for how to approximate the derivatives. That's included in this. So in these books you will find a lot of questions. Just try them, and there is another book that I've already suggested to you. Just look at the exercise, try the questions. But the main thing is to remember, what is going on in the algorithm. If you have no issues and like no questions, then I will stop in some minutes, 10 minutes.
Hello.
Yes, Nasir.
Sir, whatever we have just discussed now, that was for previous week assignment, sir. This week assignment we have got on forward difference, backward difference, central difference. So can you please start with that, sir? Because that will be really helping us for the coming Wednesday, because Wednesday is the submission
That
date.
is,
So
oh,
if you are going to discuss the one which is upcoming, that will be more helpful, sir. Thank you.
no, I just asking like, is the central differences schemes are for derivatives or what?
No, sir. It is not for derivative. Just they're given forward difference, that is delta f is equal to f of x plus h minus f of x. They have not went for numerical differentiation. That I think is next to next week. And I saw the schedule. So now they have just went for forward,
So
backward, central difference, then forming the interpolating polynomials, then Newton forward, backward.
that I've already discussed, isn't it? Next last time, the
Last time.
interpolating. Yeah,
Sorry.
last class we have discussed this.
Okay. Thank you. Excuse me, sir.
Yes.
Sir, I think last week also I asked this doubt. You gave me some tips to solve, but I'm yet to get this answer, sir. This was a question from assignment number 5.
Yeah, I've discussed that with means I have mailed, but I
Sorry, sir.
haven't got any reply.
No, I didn't got you. Can you repeat again?
You said me to email the tutor who has made the assignment, right?
No, no, that was for the last week. I'm talking
Okay.
about the week number 5. There's a
Yes,
question.
what's the problem? Yeah.
Question is for they have given two matrices, and they have
Hmm.
asked it will yeah, for Gauss-Seidel iteration method, it converges necessary for any initial guess. So
Hmm.
I gave us only option A where it is diagonally dominant, but
Yeah.
they have given both option A and B. So just I
Hmm.
wanted your help. How is option B? If you want, I can just read the matrix B with my option B. You can just
What
explain
is
how.
what is the option B?
Okay, first row is
Okay.
1 0 minus 1.
I just tried. First row is
1 0 minus 1.
yeah.
Second row is minus half 1 minus 1 by 4.
Third is
1 minus half 1.
okay. Yes.
So they have given even this is also going to satisfy. I mean, the necessity that it can be converged to any initial condition.
So is it diagonally dominant? No. But have you found out these eigenvalues of A? What is Gauss-Seidel iteration matrix? What is that?
Oh,
Are you there?
sorry. Okay. Hi, sir. I didn't know I was muted. Okay, sir. So in Gauss Seidel, now
Hmm.
since it is 3 cross 3, so we have three unknowns x1, x2, x3. So
Yeah.
x1, as soon we found, when we found, calculate the value of
No,
x2,
just find out the Gauss-Seidel iteration matrix that you know, right?
Gauss Seidel iteration matrix we found.
Like this one is that.
Okay, after finding that,
Okay, you find H, then find out the eigenvalues rho H, and it should be less than 1. Maximum absolute eigenvalue of H should be less than.
so now one doubt here is
Yeah.
now the other option it was diagonally dominant. So now after hearing this comment, now we have to find matrix H.
Hmm.
If it is diagonally dominant, then also should we find this H, or as soon as it is diagonally dominant, no need to find
No need to
this.
find.
Okay,
If
thank
it
you.
is not diagonally dominant, then you should find H, find rho H. Yeah. Okay, thanks for attending the session. I just stop it now. See you in the next tutorial.